Good day, students. How are you all? So you all managed to do the two questions I gave you yesterday. As you all know that I discussed the electromotive force problems yesterday. I give you an example, and today it's going to be another short lesson whereby I'm going to discuss the balance two questions at page 54. It's the part 6 of our lesson. And after that, which I'm going to discuss also about electromotive force and internal system, how to determine them by experiment, okay, which I also said yesterday. So today lesson going to be two things: solution of the two questions, after which experiment to determine electromotive force and internal resistance of a given electromotive source. Okay, it's a battery or dry battery or wet cell. How to determine the EMF and the internal resistance, which we will going to discuss later. Okay, so to start with, I hope you all have tried the questions. So you can look at the solution, how you are going to carry out. It's quite a direct and simple question. Okay, if you look at the question 2 at page 54, right, the question says a bulb M is connected to a battery by means of a switch. Okay, a voltmeter is also connected across the battery. When the switch is open, the voltmeter reads 6 volt. When the switch is open, voltmeter reads 6 volt. Okay, and then when the switch is closed, the voltmeter reads 4 point. That means when the switch is open, the voltmeter reads 6 volt, which means the EMF is 6 volt. Okay, when the switch is closed, the voltmeter reads 4.8 volt. That means this is potential difference. This is EMF. Okay, all right. So they ask first question, what is the EMF of the battery? So EMF of the battery, straight away you can give the answer, no need to calculate. Okay, the second one, they said if the resistance of the bulb M is 8 ohm, that means this bulb has a resistance of 8 ohm. Okay, what is the current passing through the M when the switch is closed? Okay, when you close the switch, there is a current passing through I. So they ask what is the value of I. So to go back to for the solutions, we can, as I told you, we can use both the equations. So here depend what is given. So here we are supposed to find what is the value of I when the resistance is 8 ohm. So since we know that the potential difference is 4.8 volt and the resistance, potential difference is 4.8 volt and the resistance is 8 ohm, so we can find the current easily by using Ohm's law, that is V equal to IR, because we are talking about the potential difference here. So the voltage is 4.8 volt, current you do not know, and that the resistance is 8 ohm. So therefore the current becomes 4.8 divided by 8, that is 0.6 ampere. Okay, so that's the value of the current. We can straightaway get by using Ohm's law for a closed circuit. Alright? Okay. So you can do that way. Alright. Or you also can use the equation over here. Okay, you can use the equation over here which states that, okay, we can use this equation to find the current. Yeah, I think we can. You don't need to use. You can. This is straight away you can use. Okay, and then the part C. What is the value of R? Internal resistance R. Okay, to use the internal resistance R, we can use either one equation. So to answer part C, what is the internal resistance? I can use this equation V plus IR. Okay, since we already know that EMF is 6. When you close the circuit, the voltage is 4.8. When you close the circuit, remember the current flow is 0.6 ampere, and then the resistance R. Because we can use this because when the circuit is closed, we already determined the current for 4.8 volts. So therefore, your R is going to be 6 minus 4.8 divided by 0.6, which will give you 2 ohm, 1.2, so it will give you the 2 ohm. This is one way to solve using this equation. You also can use the other equation, V equal to IR plus R, okay, to determine. So you know that your EMF is 6 volt. Current we already determined 0.6 when the resistance is 8 ohm plus R. You can use this. This is another solution for C. So 0.6 divided by 0.6 is equal to 8 plus R. So 6 divided by 0.6 you get 10. So 10 minus 8 is equal to R. Therefore your R is equal to 2 ohm. So either way you can get your solutions for this problem. Okay, so that's end of question 2. Okay. Let us now see the last question. Page 54. When the switch, okay. So you please refer your solutions. Let us look at the second question. Okay. Okay, the second question, if you look at the diagram, is given as this. The battery is put it in there, put the battery in this way. Right. So here's an ammeter. And there is a resistor here. Okay, and here we give you a voltmeter which is fixed parallel to the battery. Okay, alright. So they said when the switch is open, okay, the switch, when the switch is open, the voltmeter reading is 1.5. So when the switch is open, remember, whenever the switch is open, voltmeter across the battery will give you the EMF. So straight away we can write the EMF. When the switch is closed, when the switch is closed, when you close the switch, that means it is potential difference. Okay, so the potential difference is given as 1.35 volt. Okay, and of course when you close the switch, voltage is this, the current flow is given as 0.3 ampere. So it's quite direct. Okay, they ask what is the EMF, so we already answered the first part, EMF. B, the internal resistance. Okay, to give you the internal resistance, we can use either one equation. So we say V plus IR. We can use this equation because what is given? EMF is given, voltage given, current given. So all the three things are there. We can determine the internal resistance easily. So we can just put 1.5, 1.35 plus 0.3 R. So therefore 0.3 R is equal to 1.5 minus 1.35. So your R is going to be 0.15 divided by 0.3, which will give you 0.5 ampere. Okay, 0.5. Sorry, 0.5 ohm. So just check your working. 1.5 minus 1.5 minus 1.35 divided by 0.3. So it gives you 0.5 ohm. Okay, so that's the internal resistance. And finally they ask what is this resistance R value is. Okay, so for this we have since the circuit is closed, they give you the voltage and current, so you can solve easily by using Ohm's law. V equal to IR. This is potential difference. So potential difference 1.35, current is given 0.3. And the resistance. So R is 1.35 divided by 0.3. So this will give you 4.5 ohm. So that's your external resistance. That answers the part C. Okay. Alright. So, or you also can use the other equation, the electromotive force equation, which involves external resistance and internal resistance. Okay. Right. Okay. The external resistance. Okay, so we can use to find this. You also can use this equation. EMF is equal to I R plus R. Okay. So EMF is already fixed value. Don't forget that. It's already 1.5. Current given for 0.3. Okay. Your external resistance you do not know. Your internal resistance you already determined earlier. Okay. Plus 0.5. So we can work out here 1.5 divided by 0.3 give you R plus 0.5. So this will give you 5 ohm. Minus the 0.5. Also you will get the same 4.5 ohm for external resistance. Okay. So it's the same thing. Yeah? You can use this equation or you can use the Ohm's law. Okay. Use the Ohm's law is quite direct because closed circuit we can use Ohm's law. Alright. Or you can use the same closed circuit with this equation. Okay. So with that, I hope you have found the solutions for both the question. Please recheck your working. Okay. Now finally we are moving into the determine the EMF and internal resistance R. So this will be in page 55. Alright. So now we are going to do an outline on the experiment, how to determine EMF and also the internal resistance for a given battery. Okay, so for this there's a slight mistake in your notes. I shall correct it later. Okay, so first we shall look at the diagram. Okay, so what I want you to do is, this diagram also is not that accurate. Okay, to determine the EMF. So if you please look at your diagram, it's given like this. The diagram is given like this. These they indicate as internal resistance. Okay, outside here they have a rheostat. Okay, and then they put a voltmeter across here. Put a voltmeter across here, and here is an ammeter. Okay, over here they put a resistor. Okay. So what I want you to do is, so take away this, this one no need, this part no need. Please erase, cancel the external resistor here, okay, from the diagram. So this is the question, first correction in the diagram. You only need the rheostat and a voltmeter, okay. This voltmeter you can put here or you can put across here, no problem. Okay, so what we are going to do now, if you look at the procedure they mentioned, it's a simple 3 procedure only. Turn on the switch. Okay, you can have a switch here. Okay, you put a switch here, no problem. So you turn on the switch. Adjust the rheostat until the ammeter is 0. Okay, so you adjust your rheostat until your ammeter is 0.2 ampere. Record the voltmeter reading as V. Okay, and after that you adjust your rheostat. Okay, so that means first you have A, okay, and then your B. Alright, so first you have 0.2 volt, 2 ampere, and based on the note 0.3, 0.4 and 0.5. So for each value of this, alright, with the rheostat adjustment you take down your reading, your voltage reading, okay, V1, V2, V3 and V4. In fact, what you can do, you can open the switch, okay, and then also when you open the switch, of course your voltmeter have to put here, put here. You can put it here, but if you open the switch, you cannot put across the rheostat. You only can put across the battery. So when you open the switch, of course there is no current, so you will get one reading. Okay, this is actually what open switch is actually EMF. So you can leave it like that, or you can just ignore this. You can put a rheostat across here, and then you can carry out as what is mentioned in the notes. Okay, whatever it is, what you will get is, as you increase the current, you will find that this is a manipulated variable over here. Okay, current with the unit ampere, voltage. So when the switch is open, okay, you can get a reading here. And as you increase the current, you will find that the voltmeter reading becoming lesser and lesser and lesser. Okay, so you will get this graph. Okay, this is the graph you are going to get for this. This is different than Ohm's law. Okay, in Ohm's law, we will have another external resistor, and we measure the voltage across it. That's why I asked you to erase away the diagram. So actually, that is for your external resistor where you want to determine your Ohm's law. This is not Ohm's law. Okay, you are going to determine the EMF, so you have to put your battery across one resistor only, rheostat. Okay, and then you do. So what you get here is this. Okay, now we are going to analyze from this graph how are we going to get the EMF and also the internal resistance. Okay, alright. So look carefully. This is V versus I. So if you look at our equation, EMF is V plus IR, right? External voltage plus voltage loss. IR is voltage loss. Okay, so since this is V, this is I, so I rewrite the equation. V is equal to this, you bring it over here, so it becomes negative IR plus epsilon. Okay, so which I also can write as V is equal to negative Ri plus epsilon. It's the same, right? V, negative IR, I can write as negative Ri plus epsilon. So if you look at this equation, V is y-axis, X is your I, so this is Y equal to mx plus c. You can see that a linear equation that you learn in your modern maths, alright, for a straight line. So your V represent y-axis, your I represent x-axis. Therefore, your gradient of the graph will give you the internal resistance. So if you find, as you all know that this is a negative R gradient, right? So the negative R will give you the internal resistance. Okay, and then the interception C is actually your EMF. Simple as that. Okay, if you go back to your notes, please look at the second paragraph. They give you the equation, but in the equation over here they wrote it. First they wrote E is equal to V plus IR. Okay, but in the second row they give you V is equal to negative IR plus V. Okay, so there is a mistake. This is a mistake. Okay, this is supposed to be E. Please correct it. This is E is actually your epsilon. Already epsilon. E, they put it as E. So please correct this. This is a mistake in your notes. So we already got. So that means a simple experiment with the rheostat. This internal resistance is inbuilt electrically. Okay, so you just adjust your rheostat, get the various value of for I, and then the corresponding value of V. When you plot your graph, you will get this graph. Right? So from the graph, the gradient will be given by the internal resistance, and the interception and y-axis will give you the EMF. So for the part, so if you are given a graph, then you are given a graph for EMF, right? So be like this. Okay, let's say you are given a point here. This is, let's say, 2, and then they give you one point over here. Let's say this is 0.5, and then this is, let's say, 1.2. Okay, let's say they ask you to find the EMF and the internal resistance for this from this graph. So EMF, straight away you can get, that is 2 volts. Okay, and then you want to find what is the internal resistance. So internal resistance we can see V equal to negative IR plus epsilon. So V is 1.2, okay, equal to negative I, negative, there we put the negative, I is 0.5, that's the current. Internal resistance you do not know, and then your EMF is 2. Okay, so from here you can work out your R is 1.2 minus 2 divided by negative 0.5. 1.2 is 0.8. 0.8 divided by 0.5. So you get 1.6. 1.2 minus 2. Okay, divide by 0.5. So it will give you Here we get negative, negative, so it becomes 1.6 ohm. So that's your internal resistance. So this is how we determine internal resistance and EMF from the graph given. Okay, so that's an example. So anyway, that's one question at page 55 for you to try. Alright, the last question, I've given you an example. You can review over and over again, and then please try this question. So in the next class, I shall discuss the solution for this question. Then I'm moving on into the last part of the chapter, that is electrical energy and electrical power, which involve a concept that you already learned earlier about electrical energy. So you're just going to bring in your Ohm's law and the electrical energy concept to come up with the about 3 equations relating energy and power. Okay, so I think with that we can end today's lesson. So I hope you've been following my lesson. So some of you say that you can't get it in the Google Classroom. Anyway, I've uploaded, I got to check, but it's already in the Telegram, so you can review. And please, you also can post the questions in the Telegram. Alright, anything you are not clear, so I'll be very pleased to answer whatever doubt you have as far as the lesson concerned. Okay, so with that I end today's lesson. So we will see in another class, maybe in another a day or two, to go with the last part of the chapter. So as I've been telling, please follow the lessons. Okay, I've been seeing that some of you already followed some of the lessons already done until part 5, so I can see in the YouTube how many of you have been watching. Alright, of course others also I think is watching, the same clip maybe is relevant to them. Alright, so with that I end today's lessons. So have a good day, and just be consistent with your work. Okay, thank you very much. Bye.